طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج ديناميكس. النهاردة إن شاء الله هنستعرض مع بعض موضوع Integration of Vector Functions. Dear students of grade 3 secondary, welcome to our Maths program. Today we have dynamics. Our lesson today is Integration of Vector Functions. Definition: let f be a continuous function if we can find another differentiable function g at every point in its domain such that g dash x equals f of x, then g of x is called the inverse derivative of the function f or antiderivative. G of x is denoted by integration f of x dx. Then g of x equals integration f of x with respect to x. If and only if g dash x equals f of x. Theorem: integration x to the power n dx equals x to the power n plus 1 over n plus 1 plus c, where n not equals negative 1 and c is a constant. Example: find integration x to the power 10 dx. Number 2, find integration x to the power 2 over 5 dx. Number 3, find integration the fourth root of x power 3 dx. Number 4, find integration 1 over x power 6 dx. Number 1, integration x to the power n with respect to x equals x to the power 11 over 11 plus c. Now we add 1 to the power, then 10 plus 1 equals 11, and divided the answer divided by the new power. Then integration x to the power n dx equals x to the power n plus 1 over n plus 1 plus c. Integration x to the power 10 dx equals x to the power 11 over 11 plus c. Number 2, integration x to the power 2 over 5 dx equals, yes, we add 1 to the power, then 2 over 5 plus 1 equal 7 over 5. Then integration x power 2 over 5 dx equals x power 7 over 5 over 7 over 5 plus c, which equals 4 over 7 x power 7 over 5 plus c. Number 3, integration the fourth root of x power 3 dx equals integration x power 3 over 4 dx. We can write the fourth root of x power 3 as x to the power 3 over 4. X to the power in over out, 3 over 4. Now we add 1 to the power, then x to the power 7 over 4 over 7 over 4 plus c equals 4 fourth root of x power 7 over 7 plus the constant c. Number 4, integration 1 over x power 6 dx equals integration x power negative 6 dx. We can write 1 over x power 6 as x to the power negative 6. Now we add 1 to the power negative 6. Then the power is negative 5. X to the power negative 5 over the new power negative 5 plus the constant c, and we can write negative 1 over 5 x power 5 plus c. Note: if a is a constant, then integration ax power n dx equals a times x power n plus 1 over n plus 1 plus the constant c, where n not equals negative 1 and c is a constant. Another note: integration dx equals integration x to the power 0 dx, which equals x plus c, where c is a constant. Then we integrate dx. dx equals 1 dx. 1 dx is x power 0 dx. Then the integration of x power 0 is x power 1 over 1, which is equals x and the constant c. Note number 3. Integration a dx equals a integration x power 0 dx equals ax plus c, where c is a constant. Note number 4. Integration f1x plus or minus f2x plus or minus f3x plus or minus f4x plus or minus and so on to fnx with respect to the variable x equals integration f1x dx plus or negative plus or minus integration f2x dx plus or minus integration f3x dx and so on to integration fnx dx. Let's study theorem 2. Theorem 2, if a and b are two constant, then integration the bracket ax plus b all to the power n dx equals ax plus b all to the power n plus 1 over a times n plus 1 plus the constant c, where n not equals negative 1 and c is a constant. In theorem 2, we have a bracket ax plus b all to the power n, and we note that x to the power 1, x of the first degree. Then we add the power n, we add 1 to the power n, then the power of the new power equals n plus 1, and we divide it by the new power. Multiply the derivative of the function inside the bracket. The derivative of the function inside the bracket, we get a. The derivative of ax is a, and the derivative of b is 0. Then integration ax plus b all power n dx equals ax plus b between two brackets to the power n plus 1 all over a times n plus 1 plus the constant c. Dear students, let's start with the first example. Find, number 1, integration 2x minus 3 all to the power 6 dx. Number 2, integration x minus 3x all to the power 4 dx. Now we have integration bracket 2x minus 3 all to the power 6 and x of the first degree. Then we add 1 to the power. Then we get 2x minus 3 all to the power 7. And we divide it by the new power, which is 7, multiply the coefficient of x or the derivative of the function inside the bracket. Then integration 2x minus 3 all to the power 6 dx equals 2x minus 3 all to the power 7 over 14 plus c. Number 2, integration bracket x minus 3x all to the power 4 dx equals, yes, 11 minus 3x all to the power 4 plus 1, which is 5, over 5 multiply the coefficients of x, which is negative 3, or the derivative of the function inside the bracket, plus the constant c. Then we can write negative 11 minus 3x all to the power 5 over 15 plus c. Theorem number 3, integration bracket f of x all power n equals f of x all the power n plus 1 over n plus 1 plus c, where n not equals negative 1 and c is a constant. Now we have a function f of x not of first degree. Then we have f of x all power n multiplying the derivative of the function inside the bracket. when we have a function f of x all power n multiply f dash x, which is the derivative of the function inside the bracket, then the integration equals f of x all power n plus 1 over the new power n plus 1 plus the constant c. Example, find number 1 integration x power 2 minus 3x plus 5 all power negative 7 multiply 2x minus 3 dx. Number 2, find integration between two brackets 3x power 2 minus 2x plus 1 all the power 11 times between two brackets 3x minus 1 dx. Number 1, integration the bracket x power 2 minus 3x plus 5 all power negative 7 times 2x minus 3 dx. Now we have bracket. X inside the bracket is not of first degree. X here is the second degree. Then we have another bracket 2x minus 3, which is the derivative of the function inside the first bracket. If we derivative x power 2, we get 2x. And the derivative of negative 3x is negative 3. And the 5 is a constant. Derivative of 5 equal 0. Then we can add 1 to the power x power 2 minus 3x plus 5 all power negative 7 plus 1 equals negative 6 over the new power negative 6 plus the constant c. And we can write negative x power 2 minus 3x plus 5 all power negative 6 over 6 plus the constant c, which equals negative 1 over 6 times x power 2 minus 3x plus 5 all power negative 6 plus the constant c. Number 2, integration the bracket 3x power 2 minus 2x plus 1 all to the power 11 multiply 3x minus 1 dx. Now we have a bracket 3x power 2 minus 2x plus 1, the expression inside the bracket of the second degree. If we derivative this expression, we get 6x minus 2. But the another bracket is 3x minus 1. Then we can multiply half before the integration. Half integration 3x power 2 minus 2x plus 1 all the power 11 and multiply 2 by the second bracket. 2 multiply 3x is equal 6x minus 1 times 2 is 2. Now we have two brackets. The first bracket 3x power 2 minus 2x plus 1 all the power 11. When we derivative the function or the expression inside this bracket, we get 6x minus 2. Then the integration equals half multiply 3x power 2 minus 2x plus 1 all the power 12 over 12 plus the constant c. And we can write it as 1 over 24 multiply the bracket 3x power 2 minus 2x plus 1 all power 12 plus the constant c. Now we discuss the integration of trigonometric functions. Theorem. Integration sine x dx equals negative cosine x plus c, where c is a constant. When we integrate sine x, we get negative cosine x. Number 2, integration cosine x dx equals sine x plus the constant c. Number 3, integration sec power 2 x dx equals tan x plus the constant c. Now we can use the trigonometric integration in the following examples. Notes. Integration of sine ax dx equals, here we have a is a constant and a not equal 0. Then the integration of sine ax dx equals negative 1 over a times cosine ax plus c. Here we have a is a constant not equal 0. When we integrate sine ax, first we divide it by the derivative of the function ax, which is a. Then the integration of sine ax dx equals -1 over a cosine ax plus the constant c. Number 2, integration cosine ax dx equals 1 over a sine ax plus c, where c is a constant. Number 3, integration sec power 2 ax dx equals 1 over a tan ax plus c, where c is a constant. Here we integrate cosine ax or sec power 2 ax or sine ax. We can derivative of the angle ax equals a. Now we say 1 over the derivative of the angle 1 over a before the integration of cosine or sec power 2 or sine ax. Integration of vector functions. Definition. Theorem 1. If the function f is continuous on the interval, closed interval a and b, and f is any antiderivative to the function f on the same interval or in the same domain, then integration of f of x dx from a to b equals f of b minus f of a. For example, integration 2x minus 5 dx from -1 to 3. First, we can find the integration of 2x minus 5, which is x power 2 over 2, 2 over 2. We can cancel 2 over 2. Then x power 2 minus 5x is the integration of 2x minus 5 from -1 to 3. Now we can substitute about 3 power 2 minus 5 times 3 minus -1 power 2 minus 5 times -1. The first bracket, 9 minus 15 minus 1 plus 5, which equals -6 minus 6 equals -12. Now, we're deducing the velocity and displacement. If a, the acceleration, equals dv dt, then integration a dt equals integration dv, or integration dv equals integration a dt. Then the velocity equals integration a, which is the acceleration with respect to the time t. Now we can find the relation between the acceleration and the velocity by using the integration. The velocity v equals integration of a dt. To identify a single acceleration of motion to be a congruent to the given acceleration at. Here a is a function in the time t. The initial conditions for each of the initial velocity v naught and the starting position or initial position x naught should be started when t equals 0. The indefinite integration can be replaced by the definite integration with the proper limits of integration. Then we obtain integration dv from v naught to v equals integration a dt from 0 dt. Integration of dv is v from v naught to v, and the right hand side integration of a dt from 0 to t. The left hand side we can replace v by v minus v naught. Then v minus v naught equals integration a dt from 0 to t. The integration of acceleration with respect to time from 0 to t equals the area under the acceleration time graph. And if the acceleration is constant, then v minus v naught equals a integration dt from 0 to t. And v minus v naught equals a times t. And we have the rule v equals v naught plus at can be used in the examples only when the acceleration is constant, but if the acceleration is a function of time or variable, then the equation v equals integration a dt or v minus v naught equals integration a dt from 0 to t in regard to the data of the problem. Now we have two cases. If the acceleration is constant, then v minus v naught equals a integration dt from 0 to t. But if the acceleration is variable or function of time t, then v minus v naught equals integration a dt from 0 to t. If the velocity v equals dx dt, then integration v dt equals integration dx. Integration dx equals integration v dt, then x equals integration the velocity v with respect to the time t. Now we have a new relation between the position vector x and the velocity vector. Use the definite integration and the proper limits of integration to find that integration dx from x node, the initial position, to x, which is the terminal position, equals integration v dt from 0 to t. And we can find the integration of dx, which is x, from x node to x, equals integration the velocity v dt from 0 to t. Now, x minus x node equals integration v dt from 0 to t. X minus x node is the displacement. Then s, the displacement s equals integration v dt from 0 to t. This equals the area under the velocity time graph. If the acceleration is constant and the velocity v can be substituted from the equation v equals v naught plus at to find the relation x minus x naught equals integration v naught plus at dt, which time from 0 to t, and x minus x naught equals v naught t plus half at squared, and x equals x naught plus v naught t plus half at squared. Dear student, note that x minus x naught equals the displacement s, or s equals x minus x naught. Then x minus x naught, we can replace x minus x naught by s, then s equals v naught t plus half a t squared. This relation is the initial velocity and displacement time function. Now, if the acceleration a equals v dv dx, then integration v dv equals integration a dx. Use the definite integration and the proper limits of integration to find that integration v from v naught to v, integration v dv from v naught to v equals integration a dx from x naught to x. Integration of v is half v power 2. Then half v power 2 from v naught to v equals integration a dx from x naught to x. Now we can substitute about v and v naught. Then half v squared minus v naught squared equals integration the acceleration a dx from x naught to x. This relation equal the area under the acceleration displacement graph. At the constant of acceleration a, then half v squared minus v naught square equals a x minus x naught, or v squared minus v naught squared equals 2a times x minus x naught. Then v squared equals v naught square plus 2a times x minus x naught. And we know that x minus x naught equals the displacement s, then v squared equals v naught square plus 2as. Dear students, remember that the symbols x, s, v, and a are used to refer the algebraic measures for each of the position, displacement, velocity vector, and acceleration vector respectively. Now we have an example. A particle starts to move in a straight line from the origin point with initial velocity of magnitude 8 meters per second, and the acceleration of motion after t second is given by the relation 3t minus 2. Find each of the velocity of the particle and its displacement after 2 seconds from starting of motion. Now we have the relation acceleration equals 3t minus 2, and we know that the acceleration a equals dv dt, then dv dt equals 3t minus 2. Then the integration of dv from a to v, 8 is the initial velocity and v is the terminal velocity, or the velocity at any time, equals integration the relation 3t minus 2 with respect to the time t from 0 to t. 0 is the time at the initial motion. Then the integration of dv is v from a to v equals integration of 3t is 3 over 2 t power 2 minus the integration of 2 is 2t from 0 to t. We can substituting about v, then v minus 8 equals 3 over 2 t power 2 minus 2t. We can write the velocity v equals 3 over 2 t power 2 minus 2t plus 8. Now, when the time t equals 2, then v of 2 equals 3 over 2 times 4 minus 2 times 2 plus 8, which equals 10 meters per second. And the velocity v equals 3 over 2 t power 2 minus 2t plus 8. And we know that the velocity v equals dx dt. Then dx dt equals 3 over 2 t power 2 minus 2t plus 8. Integration of dx from x naught to x equals integration of the relation 3 over 2 t power 2 minus 2t plus 8 from 0 to t. Integration of dx is x from x naught to x equals half t power 3 minus t power 2 plus 8t from 0 to 2. Then x minus x naught equals half t power 3 minus t power 2 plus 8t from 0 to